Okay, so I left you here with something that you probably have never seen before, on the heels of something that you probably had never seen before at the end of yesterday, which was negative exponents. Yes, if you must. When you figure out negative exponents, we talked about why it works, okay? So now we need to do this. You all know how to do this with your calculator. I would like for you to do this now. Take your calculator and enter that. How do you put that in your calculator? 9 exponent button 0.5 equals. Tell me what you get. 3. This one, you need to put in, and please do this the way I am typing it, or the way I'm writing it. 27 exponent button bracket 1 divided by 3 close brackets equals, and tell me what you get. 3. Lovely. For this one, you can do 625 exponent button 0.25, and tell me what you get. 5. Now, all of you should be, when you see those 3 things, they should make you say, hey, wait a minute. I've seen something to do with 3, an exponent, and 9 before. What is it? 3 squared equals 9, yes? I have seen something with 327 and an exponent before. What is that? 3 cubed equals 27. I have seen something with 5, 625 and an exponent before. 5 to the 4th equals 625. You all have seen that already, yes? Okay. What do you know about the square root of 9? It's 3. What do you know about 9 to the 1/2 that you just found out? It's 3. What do you now know about 9 to the 1/2 and the square root of 9? They are equal. What do you know about the index in square root of 9? It's a 2. What do you know about the exponent here? It's a 1. What do you know about the denominator here? It's a 2. What do you know about the numerator here? It's a 1. Now put that together into a nice handy-dandy little law. X to the y over z equals what? The z root of what? X to what power? Y. Everybody got it? It's not complicated, but people screw it up. So looking here, does a fractional exponent make sense? Does taking 9 and multiplying it by 9 half a time make sense? No, just like multiplying by a negative exponent doesn't make sense. So math guys had to make it make sense. They made negatives make sense by doing the reciprocal thing, which I explained to you yesterday, right? 2 to the 5th over 2 to the 8th, 2 to the negative 3rd has to be 1 over 2 to the positive 3rd. Talked about that yesterday. So here they did the same thing. When you see a fractional exponent, the denominator becomes the index, the base becomes the radicand, and that whole thing is written to the 3rd power. And then you evaluate it. What is the square root of 0.04? You should not need your calculator. What is the square root of 4?
0.2.
2. What is the square root of 4/100ths? 2/10ths, which is 0.2. To what power?
3.
3. What is 2 cubed? 8. How many decimal places will I need if I multiply this thrice? 3. 1, 2, 3. And what goes in the empty spaces? Zeros. Now that's the math you actually were probably doing, were you to have done this in your head. But what you were really doing was this. You were getting the square root of 4 100ths, weren't you? Right? What's the square root of 4? 2. What's the square root of 100? So I had 2 tenths cubed, yes? That cube goes to which parts of the fraction? Both. So it became 2 cubed over 10 cubed. That looks like 103, not 10 cubed, you moron. 10 cubed, which is 2 cubed is 8. 10 cubed is 1,000, which is, of course, 0.008. Is everybody good? It's all stuff you know from the 8th grade. We're just doing something a little different with it. So looking at this next one, it makes no sense. You can't take 27 and multiply it by itself 4/3 of a time. So we have to do what is the only thing that makes sense, which is take the denominator and make it what? The index. What's the radicand? 27. And that whole thing is to what power? 4. What is the cubed root of 27? I'm going to write it all out, right? Because I want you guys to see what's happening. The cubed root of 3 cubed, I take out a group of 3. I've got 3 to the 4th. And what is 3 to the 4th? 81. Everybody good? Yeah? Okay. Now look at C. C looks weird. But you have all the tools you need to do it. If this was not a fraction, what would you do with 2 and that exponent? Add it? Over brackets, you would multiply. So do you think the rules change? No. What is 1/3 times 2? This is not a trick question. Here is 1/3. Now multiply it by 2. That makes what? 2/3. Okay. 8 to the 2/3. Now do you know what to do with it? Yeah. What do you do with it? Cube root of what? 8 to what power? 2. What is the cubed root of 8? 2 to the 2, which is 4. Can everybody do this? Okay. The problem that I find when I'm teaching this to kids is they aren't looking at what they're doing. They're looking at what, this is stupid to say, but they're not seeing what they're doing. They're seeing what's on the paper. So they look at this one right here and they say, I don't know what to do with that because it looks weird. But you do know what to do with that, don't you? Even if you didn't have a calculator, you could figure this out. Because 0.49 is 49 over 100, right? Right? All that is to the 1/2. What does the numerator become? The denominator become? The index. 49 over 100. What's the square root of 49? 7. What's the square root of 100? So this is 7/10. What's that as a decimal? 0.7. Now, I would like to take this moment to give you guys another little shortcut that a lot of people screw up. What is the square root of 49? Yeah? So, does that mean 4.9 has a square root? No. Why? There's one decimal. right? Because this is really 4 9/10, isn't it? Does 4 have a square root?
Yes.
Does 9 have a square root?
Yes.
Does 10?
No.
No. Does 0.49 have a square root? We just found out it does. 0.7, right? Does 0.049 have a square root? No. Why? Because it's got 3 decimal places, and that's 49 over 1,000. 1,000 does not have a square root, right? What about 0.0049? So that's a no. That's a no. What about that one? Yes, because that is 49 over 10,000. 49 square root is 7, 10,000 square root is 10, or is 100, right? Are you seeing the pattern here? $49.0 had a square root. 4.9 didn't. 0.49 did. 0.049 didn't. 0.0049 did. What will the next one be?
No.
No. Why?
Because it's to be 100. It's just the pattern.
Odd number of decimal places, right? So what if I go the other way? Does 490 have a square root?
No.
No. Does 4,900?
Yes.
Yes. Does 49,000? No. Does 490,000?
Yes.
Yes. Do you see what I am doing? Okay. Let's look at E. What's different about E?
It's a decimal.
It's a decimal exponent. What is every decimal?
A fraction.
A fraction. What fraction is that?
1 and a half.
1.5, which is? It's to the 1.5. How do I turn that into something I know how to work with?
That's 3 over 2.
3 over 2. Do I know what to do with that?
Yeah.
What do I do with that? What does the denominator become? The index. What does the base become?
Radicand.
The radicand. What does the numerator become?
Exponent.
What's the square root of 16?
4.
4 to the third. What is 4 to the third?
12.
64. Did you say 12? I think you did.
So it's not 12.
Oh, good cover. What's that one?
It's 3/4.
81 to the 3/4. So,
4
fourth root
in the 81's
of 81,
power of 3.
power of 3. What's the fourth root of 81? 3 to the third, which is 27. Can everybody deal with fractional exponents? And it's always the same. Is everybody good? Okay. Now, what's been very convenient about these 6 fractional exponent examples I've given you? They've all worked perfectly, haven't they?
Yeah.
Does that happen in math?
No.
No. So you got to know what to do if you're not in math class. Because when you're off in physics or chemistry, you're allowed to have a bunch of decimal places, aren't you? Right? Like in physics, you would never say he's falling out of the plane at 7 √5 kilometers per hour, would you?
No.
No. Right? When you're driving down the street in your vehicle, you would never say, I am driving at the square root of 900 kilometers an hour, would you?
No.
Right? We use numbers in reality, don't we? Right? So you got to be able to do that too. So how am I going to use a calculator to do this? The same way you did it with a calculator and worked out perfectly. You're going to take the base, 8. You're going to hit your exponent button. And then you're just going to do 2 divided by 5 in brackets. And that's how you do these. We, in math class, almost never do this. Because it's not an exact number. Right? That's going to give you a big yucky number. What did it give you, Sam?
2.2973961.
I lost you there. Who cares? It's irrational, right? That's the point I'm trying to make. Now, in a physics class, would we leave all that?
Yeah. No.
No, we'd round it off. Everybody okay with that? What would we do for this one? How would we punch this guy into our calculator? 0.6 exponent bracket 15 divided by 7 bracket equals. And you get another big yucky number. Everybody good? Okay. So now I'm done with all the exponent laws. Now listen to me. Please, please, please listen to me. All of those exponent laws, when they are by themselves, are very easy to use and explain, aren't they?
Yes.
Right? We all agree. The problem becomes, like all math, when you have to synthesize information. Synthesize means make it up as you go. You have all the tools you need to do the next 3 pages of work. May I see your book, please? To do page 25, 26, and 27. Okay? If you can do 25, 26, and 27 by yourself, I don't even care if you have to use a calculator for some of it. I don't even care. Then you are at, how shall I put this without hurting any feelings? You are at the bare minimum of exponent knowledge at which you must be. If you can do these notes right now not by yourself, but like without me writing it down. Everybody understand? It's the wrapper from the gummy bears. I play with things because I'm really 8 years old. Okay? You know what to do already. Now, here are some things I would like to warn you of. 1, when we are doing this, we generally, we do not evaluate. We generally leave it as an exponent, okay? Generally. Here's what I mean by that. 2 cubed divided by 3 to the 1/3. Would you evaluate that, or would you apply exponent laws to it? Is there an exponent law to apply there? They're different bases, aren't they? So is there an exponent law? So what would we do? We would evaluate it. You would evaluate it with your calculators. Do you understand me? Everybody good? What if it was this? 3a squared b over a b to the 4th. What would you do with that one? That would be exponent laws. Why? Because there's a couple of the same bases. Do you understand what I'm saying? What if I gave you this? That same question, but then I told you A equals 7 and B equals -3. Then what would you do? Evaluate, exponent laws, or both? Case.
Well, we do the exponent law to divide.
Yeah.
We subtract the numerator from the denominator. So we're gonna
Subtract the numerator from the... No. No. So for this question, the answer would be 3a to the 1, because 2 minus 1, and b to the -3. Is that allowed? Is there any part of that that's not allowed? The -3. So that would become 3a over b to the +3. Cool? Okay. And then, as I was saying, with this last one, you would simplify first, then you would plug those in. So you end up doing both. Is everybody good? Yeah? Okay, now listen to me. You already know how to do every question on the next 3 pages. You already know. I am not stupid. It's Friday, second last block. Snow is falling. You are not going to listen to me any more than you already have. I have gotten the one thing out of the way that I wanted to get out of the way. Fractional exponents. You finish this. Now, if you look on your outline, you see there's a whole crap load of worksheets that I never gave you, yes? That is because we are out of time. All right? So what I'm going to do is this. You're going to work on this right now, okay? And on Monday and Tuesday, Monday, I'm going to give you an in-class review, okay? And an in-class warm-up. And that's going to be your review for this unit, okay? Because here's why. You guys are already pretty good at radicals. And you're pretty good at exponents. You will be. The only thing that was kind of weird this unit was radical equations, right? I'm going to put 1 on your test. Just 1. So, huh? Well, to be honest, you do spend a lot of time looking at your phone. And that would be nobody's fault but yours. So, as do a great many of you, which is why I don't have a lot of sympathy for you. That'll be Monday. You will write a test, and we will do a unit that has 3 concepts in it over the course of next week. It is such a small unit that I won't even test you on it. But the stuff in that unit is needed for the next unit. You follow me? Not the stuff that you do, the concepts. Okay? So we'll finish off leading into Christmas with some work that will not really be evaluated as its own thing. Okay? Nabni. Which? There isn't a test on Monday. Monday is a review. Will be the review of this whole unit. Okay, you will test. Can't possibly be before Tuesday. Okay, and that test, which I will warn you about on Monday, will have radicals, exponents, and 1 radical equation. Okay, everybody good? Now, these exponent questions are pretty easy. Okay, that's why it's the bare minimum. All right? What's the base here? 1.5. What do I do over brackets? Multiply. So this is 1.5 to the negative 3 times negative 5. What's that? 1.5 to the positive 15, yes? Over 1.5 to the 5th. What do I do when I divide? Subtract. So that is 1.5 to the 10th. Everybody good? Everyone's good? Okay. Now again, this is a situation where something new is happening, but you apply the laws you already know. If this was a 2, it would go to everything inside the brackets, yes? Well, it's not a 2. It's a 1/3. Does it still go to everything inside the brackets? Yes. So I get 8 to what power? The 1/3. I get a to what power? 3 times 1/3, which is 3/3, right? 3 times 1/3. And I get b to what power? 6 times 1/3. Correct? Now start applying what I know. Isn't the third power the same as a cube root?
Yes.
This is the cubed root of 8 to the first power. What's the cubed root of 8? 2. Done. What's 3 times 1/3? 3/3, which is 1. A to the 1. Do we write 1?
No.
No. What's 6 times 1/3? 6/3, which is 2. So it's b squared. Done. Good? Please notice that nothing new is happening. It's the same laws you've always had. Now we're just dealing with fractions and negatives. Right? Right? Okay. Yuck. What do you remember from grade 9? Numbers go with numbers, letters go with letters, yes? So this is really 4 over 2, a to the negative 2 over a squared, and b to the 2/3 over b to the 1/3, correct? Okay, what's 4 divided by 2? 2. Negative 2 and positive 2. What math do I do there?
Subtract.
A to the 2, negative 2 minus 2, right? Okay, and what's b? 2/3 minus 1/3.
1/3.
2/3 minus 1/3. Now I simplify. 2 is already simplified. What's negative 2 minus 2?
-4.
A to the negative 4. What's 2/3 minus 1/3?
1/3.
B to the 1/3. What there is not allowed?
Negative.
Negative. So the 2 doesn't move. The b is allowed, so he stays the same. B to the 1/3. Where does the a have to go?
Underneath.
Downstairs. And what happens to his exponent?
Becomes positive.
Becomes positive. Nothing new. What you already know. Everybody good? All right. Now let's look at 10 and think real carefully, because there's a lot of different ways to do number 10. If this was grade 7 and you had just learned bed mass, what would you do? Inside the brackets. So we wouldn't even care about this 1/2, would we? So, inside the brackets, numbers go with numbers. So I've got 100 over 25, yes?
Yes.
And I've got a over a to the 5, yes? And I've got nothing, so it's 1 over b to the negative 1/2. Is everybody okay with that? Okay, and that whole thing is to the 1/2. We're going to deal with that later, aren't we? Because we're doing the brackets first, like good bedmasters. What's 100 divided by 25?
4.
4. What's a to the 1 minus 5?
A minus 4.
Is a to the negative 4, yes? And what's nothing here? Where does this negative 1/2 have to go? Is that allowed?
No.
Where does he have to go? He's already in the denominator, so where does he go?
Numerator.
Up to the numerator, and he becomes, what happens to his exponent?
Positive.
Becomes positive. Is everybody cool to there?
Yes.
Okay. Now, what is that whole thing? It's all to the 1/2, yes?
Yes.
Where does that 1/2 go? To everything, right? So the 4 gets 4 to the 1/2. We were doing so well. The 4 gets the 1/2, yes? What do we do with A? What do I do over brackets? What do I do over brackets? Multiply. What's 4 times 1/2? Negative 4 times 1/2, sorry, is -2, yes?
Yes.
What is 1/2 times 1/2? 1/4. Now, can I fix any of that up? 4 to the 1/2 is just square root, isn't it?
Mm-hmm.
What's the square root of 4? 2. Is a -2 allowed to be anywhere?
No.
So where does it go?
Numerator.
Down to the denominator. Is b to the 1/4 okay?
Yes.
Yes, because he's positive. Is there another way I can write this that is just as acceptable? 2 4th root b over a squared. Both of those are okay. Is everyone all right? Okay, so you guys finish page 25, and Monday I'll give you an assignment. On Monday, I'll give you just some exponent questions, and I'll give you something to cover everything you need for this whole unit. Deal? And then we'll test on Wednesday, because Tuesday we'll mark. Tuesday I want to have reserved to mark in case we don't get through everything on Monday. Fair enough? Scarlett, is your hand up or are you stretching? Okay. Everyone is good? Go.